Hi everybody. On today's show, we put our translating skills from the previous lesson to use while we model with linear equations. So we're going to be creating linear equations that model these situations, and we're going to have to translate to get to our equation. So let's look at this opening exercise. The length of a rectangle is 2 meters less than 3 times the width. Draw a picture and write an expression. So they're talking about a rectangle. And it says the length here, which I'll call L, the length is 2 meters less than 3 times the width. So it's 2 less than, so I'm taking away 2 from what? 3 times the width. So the length here is 3W's minus 2, whereas the width is just the width. So draw a picture and write an expression that represents the perimeter. So the perimeter is the total distance around the figure. How far am I traveling? 3W, 6W, 7W. The perimeter is 8W, but I'm subtracting away 4. That's the perimeter. Using the rectangle from above, determine the dimensions. The dimensions of the rectangle are the length and width. If the perimeter is 36, so they're telling us the perimeter is 36. Well, wait a minute. That's the perimeter. So 36 equals 8W minus 4. I can use the addition property of equality to add 4 to both sides. 40 equals 8W. When I divide by 8, I get 5 equals W. But I'm not done because it asks for the dimensions. So I need both the length and the width. So let's go up to this rectangle here. How big is each side? That's 5 and that's 5. Well, the length is 3 times 5 minus 2. 15 minus 2 is 13. Both of those sides there are 13. So if 5 is the width, 13 is the length. Those are my dimensions. It's a 5 by 13 rectangle. A rectangular garden has a width that is 3 feet more than twice the length. It takes 42 feet of fence to completely enclose the garden here. Write an equation. Okay, so I need to make an equation from this, but let's stop. Let's draw a picture. Let's draw a picture here. I have a length and a width. The width is 3 feet more than twice the length. 3 feet more than, so I'm adding on 3 feet to twice the length. So 2L plus, sorry, that's not there. So the width, that's not the width, that's the length there. The width is 2L plus 3. That's the length, and then this side is also a width, which is really 2L plus 3. So write an equation here. Well, what else do I know? It takes 42 feet of fence. So to put up my fence around this garden here is 42. Well, the fence represents the perimeter. So the perimeter equals, well, let's go travel around. 2L, 2L, 3, 2L, 2L, that's 6 L's, plus 6 gives me 42. We can solve this equation here. 36 equals 6L, which gives me L equals 6. L equals 6. Well, let's say L equals the length and W equals the width. Notice here it didn't actually ask us to solve it, it just asked us to write it, so we were actually done at that step right there. Down here we're going to solve it, but that's okay, it didn't take us too much work. Explain how your equation models the given situation. So 42, explain means a sentence, is the perimeter. So I added all the sides together. 42 is the perimeter, because that's the fence, and I added all the sides together. Find the dimensions of the garden algebraically. So up here I already solved the equation and got the length equals 6, even though I wasn't supposed to. How do I get the width? Well, the width is 2 times 6 plus 3. I'm going to plug it back in to my garden up there. The width must be 15. So the dimensions are 6 by 15. That's the dimensions for my garden. Create an equation to solve this problem. The length of the rectangle, so I'm still dealing with rectangles here, is the length, so length is 1 foot more than twice the width. So I'm adding on 1 to 2 widths. So if this is the width, this side is the length. The area, that's the inside shaded part, is 55. Well, how do I find area? Well, area is length times width. It's the product of the length and width. Gives me 55. So 2w squared plus w equals 55. Notice this has a w squared. This is not linear. It is quadratic. We won't solve quadratic equations until March, so we can only solve linear, just plain old w's. We can't deal with w squareds, and that's what happens when we work with area, is we get these w squareds, but we'll deal with that later in the year. I just want us to notice we can't solve this equation right now because of that w squared. But it's not always about rectangles. Pause the video and see if you can work on question 4 here and see how you do. When you come back, unpause the video and I'll talk through the answer. The perimeter of a triangle, so I'm working with a triangle here, changing it up. The perimeter is 47. The second side is 6 inches longer than the first side. The third side is 1 inch longer than twice the first side. So I have no idea what the first side is. Let's let x be the first side. The second side is 6 inches longer than that. So that's x plus 6. The third side is 1 longer than twice the first. So I need to twice the first and add 1 to it. How long is each side of the triangle? Well, the perimeter is telling me to add all of those up. I need to add all of those sides together here. How many x's do I have? 4 plus 7 equals 47. If I subtract 7 from both sides, I get 40 equals 4x. Well, what times 4 gives me 40? Well, 10 equals x. But I'm not done. How long is each side? The first side is 10. The second side is 16. How did I get that? 10 plus 6 is 16. The third side, plug in 10, is 21. Those are the 3 sides of the triangle. So in my pocket, the total value of some dimes and quarters is $4. So the total amount of money I have is $4. And I only have dimes and quarters. Quarters is 4 more than twice the number of dimes. So the number of quarters is 4 more than, so I'm adding on 4 to what? Twice the dimes plus 4. How many do I have? So let's think about this here. I have dimes in my pocket, and each of those are worth 10 cents. Because I have to deal with money here. I'm dealing with money. I'm dealing with $4, not how many dimes, not just dimes. How much do dimes cost? 10 cents times the number. And then I need to add on quarters. So this is money from dimes. Now let's do money from quarters. They cost 25 cents. And what is quarters? I'm just going to put Q. I'm going to put that. That's quarters. And it equals $4. And I can use money here because that's money and that's money. If you didn't have that money there, you couldn't be working with money. So let's solve this equation here. 0.10d plus distributive property 0.5d plus 1 equals $4. So 0.6d plus 1 equals $4. Subtract 1 from both sides. 6/10 D equals 3. Divide by 6/10. And D equals 5. So I have 5 dimes. How many dimes and quarters? Well, dimes is 5. Let's plug it in. 2 times 5 plus 4 quarters must be 14. And let's check this. If I have 14 quarters, that gives me, how much money would that be? That'd be $3.50. That gives me 50 cents. Together, that gives me the $4 I needed. That wasn't so bad, but what happens is everyone forgets the money. Everyone forgets that the money goes in front of it there. So this last set of problems I'm not going to do in the video. They're kind of extra problem-solving problems that I want you to try. There's 3 of them, I believe. Yep, there's 3 of them here, and I want you to see how you do. See how you do with these problems, and if you choose to do them, maybe you can come check with me and show me how you did. But that's all I've got for this video, is getting to problem 5 here. So hopefully putting our translating skills to use wasn't bad, and we got to practice using those more than, less than, practicing twice that. Hopefully that was pretty helpful in developing those skills there. And I'll see you in the next video.